Okay, so with these questions here on 10.2, we're going to do operations with functions. So what we have here to start with is f of x is equal to 1 over x minus 4, and g of x is equal to x over x plus 1. Now, when we're going to be doing this, we need to make sure that we stick with our domains. And just to start off with in the very beginning, remember what domain is. So f of x, the domain is everything but x cannot equal, in this case, 4. If I plug that in, 4 minus 4 would give me 0. To write that in interval notation, the way I would write that in interval notation, again, is everything but 4 goes from negative infinity to 4. I union that with 4 to positive infinity. Over here for g of x, same idea, only the domain here, the domain x cannot equal negative 1. And again, how am I doing that? Let me just back this up a little bit and go step by step. I take whatever is in my denominator, which in this case is my x plus 1, and I say I know that x plus 1, since it's in the denominator, cannot equal 0. So that I subtract 1 from both sides, and I get x cannot equal negative 1. To write that in interval notation, it basically means that everything on the number line is good except for negative 1. So you end up making this open circle and going in both directions. So to turn that into interval notation, I'm going from negative infinity to negative 1. Negative 1 is not included, so I use a parentheses. And then I union that, doing it with it, and then I go from the other side, from negative 1 up to positive infinity. So that's the beginning portion about how to write these as the domain. But now with the first question here, part A, says they want me to add those two together. So let's go through and look at that. So I'm adding those two functions together. So what I have here, it's saying is what is f plus g of x? All that's saying is to take f of x and add that to g of x. And in this case, f of x is 1 over x minus 4. Then I add that to g of x, which is x over x plus 1. Now we are adding fractions here, so I must find a common denominator. And I do that by just multiplying whatever the other denominator is in the numerator and the denominator. So I multiply x plus 1 to the top and bottom of the first fraction, my f of x. And then for the second fraction, I multiply it times x minus 4, again, top and bottom. But do notice that what I'm doing here is I'm making sure I put parentheses around that x plus 1. So when I add those two together now, I have a common denominator. So let's take and simplify what I have in the numerator. When I simplify the numerator and I distribute the 1, that just gives me 1 times x and 1 times 1. So that gives me x plus 1. And I'm adding that to, over here in the numerator on the other side, I have x times x, which is x squared, and then x times negative 4. So that gives me x squared minus 4x. And that's over the common denominator, which is the same for both of them. Now, even though that this is written as x minus 4 times x plus 1 and x plus 1 times x minus 4, the order of that doesn't matter. So I'm just going to put them both as x plus 1 times x minus 4. I do want to simplify the numerator and put it in descending order, so that gives me that to be x squared. I combine my like terms, so my like terms here are x and negative 4x, and that combines to give me a negative 3x plus 1, again, all over my common denominator. So you want to go ahead and type that in. When you go through and type this in, first go through and do the fraction button. Then you have x squared, arrow over, minus 3. You could also type that in as 3x plus 1, and then arrow down for the denominator. And you can leave this in factored form. You do not have to multiply it out. So that becomes x plus 1. Oops, type that in there wrong. So that becomes x plus 1. And it's times x minus 4. Oops, I'm missing a parentheses. There we go. That looks better. And then we are all set with that. And that's exactly what the answer is. Now, for the domain. The domain's a little bit more complicated, so let's talk about this. If I look at the denominator, and again, the domain is always set by what can't be in the denominator. Since this is in factored form already, I set both of the parentheses equal to 0, and for the domain, I know that x plus 1 cannot equal 0, which tells me the domain cannot equal to negative 1. And the second part of this over here, the domain also x cannot equal a positive 4. I still like to always start with the number lines. I think it really helps put everything in the correct order, because when you're typing the domain into my OpenMath, it must be in the correct order or it will be incorrect. So basically this says everything except negative 1 and except 4 are okay. So what does that look like? Well, that tells me that everything here, open circle on 1, everything in between negative 1 and 4, open circle on 4. So I have my whole number line except for those two values. Well, if you look at this, I have 3 different regions I have to type in. I have this region here, the middle region, and the region on the right. So the way I go through and write that in interval notation, again, always start from the left-hand side. You're going from negative infinity to negative 1. Negative 1 is not included, so you need a parentheses. That gets unioned with the next region inside here, and that goes from negative 1 to 4. Again, parentheses because that number isn't included. If it was, we wouldn't need to do this. And then I union that all the way with 4 to positive infinity. You'll type all of that in. And if you don't, we're going to go through and just take a look at the second one with the subtraction. It's fairly nearly the same thing. The only difference between this is going to be there's going to be a subtraction sign between the two functions, but the domain is going to end up being the same. I'm going to show you that next. All right, so it still is f of x minus g of x. So now I have f of x is 1 over x minus 4, and I subtract g of x, which is x over x plus 1. Because it is adding or subtracting fractions, I need to find a common denominator. So I multiply f of x times x plus 1 in the top and bottom. And g of x gets multiplied times x minus 4 in both the top and the bottom. Now I need to go ahead and simplify my numerator. Just remember when you're doing this, we have this negative sign out here, so we really want to make sure we don't forget that when I'm working on this problem. So the first part is just 1 times x and 1 times 1, so that in my numerator gives me x plus 1. Now, the way I look at this over here is this is a negative, and I'm going to attach that to the x. So I treat all of the negative and the x as one piece, and I take all of that and I multiply it times x. So that gives me negative x times x, which is a negative x. And then it gives me, a negative x squared. And then the next one gives me negative x times a negative 4, which gives me a positive 4x. That's all over my common denominator of x minus 4 times x plus 1. I simplify the numerator and put it in descending terms, so that would be x squared plus 5x plus 1 all over your common denominator. All right. Now you'll see the denominator is exactly the same, so your domain is exactly the same for this one. Next up in our list is how do I multiply f of x and g of x? Let me just write those down again real quick. So it's f of x is equal to 1 over x minus 4, and g of x is equal to x over x plus 1. And multiplying fractions is definitely easier than adding or subtracting them. G looks a little strange, so let's fix that. All right, so multiplying this, so again, the notation tells us it's f of g of x, and that just means the same thing as multiplying f of x times g of x, or 1 over 1 minus 4, x minus 4 times x over x plus 1. When you're multiplying fractions, numerator times numerator, denominator times denominator, so it's just x over x minus 4 times x plus 1. And again, it is exactly the same denominator. Oops, I gave you a little sneak preview there. It's exactly the same denominator, so the domain would be the same as the first question. Now this last one, g, where I'm dividing the two pieces, this one is something important that we have to talk about. What you're saying here is this is f of x divided by g of x. Now, again, f of x is, as we talked about before, 1 over x minus 4, all divided by x over x plus 1. I can write it as a complex fraction like this, or you could write it as f of x divided by g of x. If I write it this way, I think you might like it a little bit better, but what that means is g of x, the entire g of x cannot be 0 in the denominator. So we have to make sure in our domain, we already know a couple of things. We can't lose that. We know that x cannot equal 4. That's not in our domain. And we know that x cannot equal negative 1. We have to have that from the beginning. So keep that in mind when we're writing the domain in a little bit. So we can do this with complex fractions or divide it like this. F of x 1 over 1 minus x minus 4 divided by x over x plus 1. I think you'll like it a little bit this way. Remember, when we divide fractions, we keep this. We change the sign and then we flip. So this turns into 1 over x minus 4 times x plus 1 over x, or x plus 1 is in the numerator because we're multiplying the two fractions together, numerator times numerator, denominator times denominator. You don't have to multiply the denominator out. You can leave it in factored form, so that would be x times x minus 4. All right, so this is going to be the answer for the division of f of x over g of x for question G. Now, the domain we have to be tricky on. Let's talk about the domain for a second, because we cannot forget what we said in the very beginning. Remember how we said in the very beginning that the domain we had two limitations on it. We started by f of x in the very beginning that x cannot equal 4 and x cannot equal 1. But if I look down to my denominator, my new denominator has one more piece inside here. And that piece is that x out front. Because there's another term in the denominator, that x also cannot equal 0. So I'm adding that to my domain for this question. So what my final domain is x cannot equal 0. X cannot equal -1, and x cannot equal 4. And it, again, why is it happening? Is because this piece right here, I know that both of those parentheses, both of those terms in the denominator cannot equal 0 and be in our domain, because that would give me a 0 underneath the radical. So again, I'm going to go back to my number line because I really think the number line helps us understand how to write this better. I know 0 is being excluded, I know -1 is being excluded, and I know 4 is being excluded. So what that looks like here is that everything, open circle on -1, open circle on 0, and open circle on 4. So I actually have, in this case, I have 4 different regions. I have region 1, region 2, region 3, and region 4. So yeah, you do need to have all 4 of those to write the domain for this question. So to write the domain, always go from left to right. I go from -infinity to -1. Parentheses, I union that for the region on the inside. I go from -1 to 0. Union from 0 to 4, and lastly from 4 to infinity. So this is a longer answer for the domain, and you must have all of them in the correct order for this to all work.